Finding completing the square hard to solve all of your quadratic equations? Fear no more! Introducing the Math Hat will make you understand everything mathematically. Hello, I am the Math Hat, and today I will help you solve quadratic equations using completing the square. If the polynomial in the equation is not factorable, make it factorable by completing the square. Steps in using the completing the square. 1. Transform the equation in the form ax squared plus bx equals c. 2. If a is not 1, divide both sides of the equation by a. 3. Solve for the last term to form a PST or perfect square trinomial and add it to both sides of the equation. 4. Factor the PST in one side and simplify the other side of the equation. 5. Apply the square root property. 6. And of course, check for the final answer. Steps in solving for the last term to form a PST. 1. Divide the middle term by twice the square root of the first term. 2. Square the quotient. The last term formula is given by middle term divided by twice the square root of the first term raised to the second power. Formula in solving for the last term to complete a square in a quadratic equation where a equals 1. C equals b divided by 2 raised to the second power. However, this is not to be used in solving for the last term of a PST, or again, a perfect square trinomial. Now, let's solve your EC equation, which is x squared plus 6x minus 10 equals 0. First, we must transform x squared plus 6x minus 10 equals 0 into the form ax squared plus bx equals c. So it now becomes x squared plus 6x equals 10 because we transposed negative 10, which is our c, into the other side of the equation and changed signs. So, from a negative, it became a positive. Since a is already 1, we can leave the equation at that. Next, we must solve for the last term to make the equation a PST. Again, using the formula for the last term, which is middle term divided by twice the square root of the first term raised to the second power. So, substituting all of our values into that formula, we would give 6 divided by 2 times square root of 1 raised to the second power, which is basically 9. Adding 9 to both sides of the equation, we get x squared plus 6x plus 9 equals 10 plus 9. We then factor x squared plus 6x plus 9 and simplify 10 plus 9 to make x plus 3 raised to the second power equals 19. This allows us to apply the square root property. So again, finding the square root of x plus 3 to the second power equals square root of 19 will give off x plus 3 equals plus minus square root of 19. Isolate x to find the solution. X plus 3 equals positive negative square root of 19. And then transposing positive 3 to the other side of the equation and changing signs, it becomes x equals negative 3 positive negative square root of 19. The final solution again, therefore, is x equals -3 plus minus square root of 19. You can check the solution by substituting it in x squared plus 6x minus 10 equals 0. It should satisfy the equation. Now for a difficult problem, which is 3x squared plus 5x minus 4 equals 0. First, we must transform 3x squared plus 5x minus 4 equals 0 into the form ax squared plus bx equals c. Again, transposing -4rc to the other side of the equation and changing signs, it becomes 3x squared plus 5x equals 4. Since a is not 1, we must divide the whole equation by a, which in this case is 3. So, dividing 3x squared plus 5x equals 4 all over 3 will become x squared plus 5 over 3x equals 4 over 3. Next, we must solve for the last term to make the equation a PST. Again, the last term formula is given by middle term divided by twice the square root of the first term raised to 2. So, substituting our values into that formula will give 5 divided by 3 times 2 times the square root of 1 raised to 2, which will give 25 over 36. Adding 25 over 36 to both sides of the equation, we get x squared plus 53x plus 25 over 36 equals 4 over 3 plus 25 over 36. We then factor x squared plus 5 over 3x plus 25 over 36 and simplifying 4 over 3 plus 25 over 36 to make x plus 5 over 6 raised to the second power equals 73 over 36. This allows us to apply the square root property. So, x plus 5 over 6 all raised to the second power, get the square root of that, equals the square root of 73 over 36 will give off x plus 5 over 6 equals positive negative square root of 3 all over 6. Isolate x to find the solution. X plus 5 over 6 is equal to positive minus square root of 73 over 6. Transposing 5 over 6 to the other side of the equation and changing the signs will give x is equal to -5 over 6 plus minus square root of 73 over 6. Therefore, the final solution is x is equal to -5 plus minus square root of 73 all over 6. You can check the solution by substituting it in 3x squared plus 5x minus 4 equals 0. It should be able to satisfy it. That is how you solve quadratic equations using flipping the square. Bye! 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 We don't exist corporation.